Hello and welcome to the final lab of this course. My name is Jack and this week I will be presenting my own idea in the Create Your Own Adventure Lab. The, pur the purpose of this lab was to observe an object falling in projectile-style motion and to then analyze the change in position for both x and y and to compare that data to a viable model created by a program. From what we already know about the fundamentals of physics and projectile motion, we can assume that position in the x direction will change at a constant rate, and therefore the velocity in the x direction will remain constant. The position in the y direction, however, will change at an increasing rate. As the ball falls, the speed increases until terminal velocity, but we won't be observing that in this lab. Therefore, the velocity in the y direction will increase. For this, I have filmed a street hockey ball rolling off a table onto the carpet. Here's a clip I used. I then used tracker software to analyze my video at each frame and plot the points between the initially rolling off and hitting the ground. I also analyzed the roll to gather data for my initial velocity. I set up my coordinate system and calibration stick in the video to get fairly accurate results. Here's some of my initial data. I then used all this information and input it into the VPython software to create the model. I used Newton's second law in my code without consideration for drag. For the purpose of this lab, drag was negligible. I then graphed my code to receive a visualized form of my model that graphed the ball moving upward. In the entire lab, everything but the actual video moves upward for the purpose of setting our origin to 0 and maintaining our usual coordinate system rather than moving downward. I saved the data for the y component from the model in an Excel CSV file that could be plotted. I also gathered my data from the y component from tracker, entered it in Excel and plotted it just the same. Through this, I could compare the two plots for the change in y. I repeated the same step for the x component data. Here you can see those just mentioned graphs. In the end, I came to the conclusion that my prediction was right. This can be explained by looking simply at the forces at work in this problem. Gravity is the only thing acting on our ball, and as always it's acting only in the y direction. If we neglect drag, which we did, the ball's velocity in the direction is not affected. Therefore we get the results we get. Thanks for watching. Hope you enjoyed the video. Feel free to discuss in the comments below.